If you are worried you have Lyme disease, or just like the outdoors, and want the peace of mind of knowing whether you have Lyme disease or not, there is a new Lyme screening test based on decades of research by Dr. Richard Marconi, a professor at VCU Medical Center. For more information, visit glymedx.com, that's glymedx.com, or email at info@glymedx.com.
Infectious diseases, research, medicine, health. Welcome to Outbreak News Interviews. And now, broadcasting from the Outbreak News Skylar Studios in beautiful West Central Florida, here is your host, microbiologist and editor of OutbreakNewsToday.com, Robert Harriman.
Hello everybody, this is Robert, and this is Outbreak News Interviews. And we're talking parasites once again. And on today's show, we'll be talking about a trematode or a fluke. That's not often seen in humans, but is fascinating just the same. It's called Dicrocoelium dendriticum. And joining me now to lend her expertise in answering questions about this flatworm is parasitology teacher and author of Parasites, Tales of Humanity's Most Unwelcome Guest, again, Rosemary Drisdelle. Hi, Rosemary. Welcome back.
Hi, Robert. Glad to be here.
Great. Dicrocoelium dendriticum, also known as the Lancet liver fluke. I would venture to guess that this may be unknown to many listeners. It is a fluke, which is a group of parasites we've been looking at recently. Where is this parasite found globally?
Dicrocoelium, I think, probably originated in Europe and Asia and is found more commonly there. But it seems to have been also introduced to North America and Australia more recently. So it's pretty much global at this point.
Okay. And it's quite common in grazing animals around the world.
It is.
However, it is, and at least I believe it is, a rare human pathogen. Can you verify that for us?
Yes, it's unusual to see human cases. It's not unheard of, though. I've seen two in my career, so It's not really, really rare.
Okay. Now, it is a trematode, thus it must have an interesting and a complicated life cycle. Am I right?
That's right, and it's the life cycle of Dicrocoelium that is so fascinating for many of us. Like many of the flukes, Dicrocoelium has two intermediate hosts. So if we start out with an infected animal, like a human, a goat, perhaps a sheep, the animal would be passing fluke eggs in its stool onto the ground. And then in the evening, when the snails are out grazing and eating vegetation, they may come along and feed on those feces and swallow some of the eggs. The parasite undergoes a period of asexual multiplication inside the snail and eventually exits the snail, which apparently is quite irritating. The snail wraps up the parasites in a slime ball, which it then leaves behind it as it travels across the vegetation. Now, ants find these slime balls quite delectable, so they'll come along and perhaps eat them or carry them back to the ant colony to feed to their young, which results in the ants becoming infected with the parasite. These parasites have they cooperate with each other, and just a couple of the parasites, an ant might be infected with 100 or more, but just a couple of them will actually migrate to a nerve and affect the ant's nervous system and cause it to climb up to the top of a blade of grass and cling there by its mandibles or its jaw parts. And they'll stay there until things get a little bit too hot and dry for them. Then they climb down and go about their business. But the next time it gets cool and damp, they climb back to the top of the blade of grass and cling there, which of course puts them in a perfect position to be eaten by a grazing animal. And so this is a perfect and fascinating example of a parasite that can affect its host's behavior in such a way that it's more likely it will be able to complete its life cycle.
Oh, that's amazing.
It is.
Now, there's a term that we haven't really talked about on this podcast series, and that's reservoir host.
Yes.
Rosemary, what is a reservoir host?
Well, a reservoir host from the point of view of a human is a host that will harbor a parasite, say, in the natural world, so that even if we were able to completely wipe it out in humans, it could come back because there's that reservoir of it somewhere in the environment.
So I would imagine the reservoir host for Dicrocoelium would be the grazing animals.
That's correct. It's very much more common in grazing animals than it is in humans.
And how do people contract this parasite?
Well, as you may have guessed, you would contract this parasite typically by swallowing an ant. Now, sometimes people don't necessarily swallow the ant, but even just water that an ant has perhaps drowned in, you could just drink that water and become infected. There have been several cases in the literature of people drinking bottled water or water from one of those water dispensers that are sometimes present in offices, the infamous water cooler, and become infected with Dicrocoelium. So ant tea will do it as well.
Now, what kind of disease do we see in humans? Does it depend on how heavy the worm burden is?
It does, as with many of the intestinal and worms and flukes that live in the liver. It does depend on how many of them you have. Human cases with Dicrocoelium are often asymptomatic. If you have a heavy infestation, you could develop a liver abscess, perhaps suffer some abdominal pain, inflammation of the gallbladder, that kind of thing. But typically, I think people don't even know that they have these worms unless they're accidentally discovered in a stool sample.
And this is not typically fatal?
No. And something we have to remember with Dicrocoelium is that when we see those eggs in a human specimen, we have to always ask whether this could be a spurious infection, meaning that the person may have eaten the liver of an infected animal and therefore be passing the eggs in the stool because they were present in the liver, but not actually be infected with the worm.
Right. We also see that with, fasciola hepatica sometimes.
That's
too.
right,
Yeah.
Yes, yeah.
Rosemary, can you describe what the adult fluke looks like and what the egg stage looks like for this parasite?
Yeah, they're pretty small, actually. The adult worms might be as much as 1 centimeter in length, but really quite small, and described as being blade-shaped. So another name for Dicrocoelium is the Lancet Fluke, because it's blade-shaped. So they're very small. You might not even notice them. And the eggs, of course, are extremely tiny. They're about 35 microns, so that's about 35 one-thousandths of a millimeter. Very tiny eggs. Quite characteristic, though, when you see them in a wet mount.
Now, is stool the specimen of choice for diagnosing this, or is there something else?
Yes, it would be a stool specimen, and as usual, we would concentrate that stool specimen in the lab so that we remove most of the fecal material and the garbage and concentrate the eggs so that they're easier to find.
And concerning treatment, is it the same type of treatment for most other helminths?
That's right. Praziquantel is the drug of choice. Of course, most of what we know about treating Dicrocoelium comes from treating animals rather than humans.
Okay. And lastly, because it is a relatively rare parasite found in people, there must be a good story behind it.
Well, not a lot of worms have been made infamous in cartoons and things like that, but Dicrocoelium is one that has. There's a website called The Oatmeal that has the life cycle of Dicrocoelium spelled out in sort of a cartoon story. It's really quite amusing. And in that story, Dicrocoelium has been nicknamed Captain Higgins.
Okay.
Yeah.
Well, I'll see if I can find the oatmeal and put a link to that on the website.
I'm sure you will enjoy it.
Okay. Well, thank you once again, Rosemary, for your time and expertise, and have a nice Thanksgiving.
My pleasure. Thank you.
Okay.